In this video, we're going to be talking about resistance and resistivity. Resistance is the measure of the opposition to current flow through the conductor. Its SI unit is ohm. The symbol is this. Ohm's law states that the current in a conducting wire is proportional to the voltage across the 2 points. So Ohm says that current I is proportional to V, volts. Now, for electric current to flow in a circuit, there must be a potential difference between two ends of the wire. If not, the electric current will not flow. Now, this potential difference is usually provided by the battery. Okay, so we can also define resistance such that current I is inversely proportional to the resistance of a given voltage. So I equal to V over R. If we make V subject of the formula, V is equal to IR. It is also experimentally discovered that resistance of a wire is proportional to the length. R is proportional to the length of a wire and inversely proportional to the cross-sectional area. Inversely proportional to the cross-sectional area. In this case, if we remove the sign of proportionality, bring in equal to, we introduce a constant rule, L over A. This rule is known as the sign of proportionality, which is the resistivity of the material, whether it is a copper or any material. Now, the unit is ohm meter. Ohm meter. That is the unit of resistivity. Resistivity is equal to R area over L. In terms of two materials, we can have that resistivity is equal to R1 A1 over L1 equal to R2 A2 L2. Therefore, R1 over R2 is equal to L1 over L2 times A2 over A1. When it is in terms of diameter, we can say that R1 over R2 is equal to L1 over L2 times D2 over D1 inverse, all squared. So let's see some examples. Now this question says a hairdryer draws 6.5 ampere when it's plugged into a 120 volt outlet. What is the resistance of the hairdryer? B. How much charge passes through it in 5 minutes? Now, the first equation, for the first question, to solve it, we know that V is equal to IR, current times resistance. Now, if you look at the question, it says a hairdryer draws 6.5 ampere. Ampere stands for current. So, current is 6.5 ampere when it's plugged into a 120 volts. So, the potential difference is 120 volts. What is now the resistance R? We can make R subject of the formula and say R is equal to V over I, which is 120 over 6.5. And when we calculate that, we'll have 18.5 ohm. For us to calculate the B question, charge, we know that charge Q is equal to current times time, IT. The I there, current, is 5 minutes. I, current, is 6.5. I beg your pardon. T, time, is 5 minutes. So what we have is 6.5 times the 5 minutes will need to be converted to seconds, which is 5 times 60. and when we compute that, we will have 1950 coulomb. Now this question says a 15-meter length of wire 1.2 millimeter in diameter has a resistance of 1.8 ohm. What is the resistance of a 25 length of wire 2.0 millimeter in diameter made of the same material? Now the first thing we can do here is to bring out the parameters given to us. The first one says a 15-meter length, which means the first length is 15 meter. 1.2 millimeter in diameter, first diameter D1 is 1.2 millimeter. Has a resistance of 1.8. The first resistance R1 is 1.8 ohm. What is the resistance? So R2, we don't know, of a 25 meter, so length, so L2 is 25 meter of wire 2.0 millimeter, so diameter 2 is 2.0 millimeter. Now, having gotten this, we know we have a formula that says that R1 over R2 is equal to L1 over L2 times D2 over D1 all squared. If we plug in all this, do we have R1? Yes, 1.8. So we have 1.8 over, we don't have R2. That's what we're looking for, in fact. L1 is 15 meters. So we have 15 over L2 is 25. 25 times our D2 is 2 over our D1 is 1.2 all squared. If we resolve this, we'll have 1.8. We have 1.8 divided by R2 is equal to, if we divide 15 and 25, we will have 0.6 times, this squared is 4, and this squared, if we divide both, we're going to have 2.778. Now we have 1.8 over R2 is equal to, if we multiply these two out, the answer will be 1.6667 approximately. So that if we make R2 subject of the formula, we'll have 1.8 divided by 1.6667, and that will be 1.08 ohm. So from here, if we make R subject of the formula, it means we cross multiply and then divide with the coefficients, which is this. So we'll have this. This is the resistance of the second wire that is made of the same material.